Resolution is a topic related to how human or camera see the world. You might have heard the word resolution associated with the quality of image, right? High resolution, nice picture. Low resolution, can't really see small details. But what is actually resolution? Let's consider one example. Imagine you were standing by a road at night. You look at the car approaching you, and you will see two headlamps, like this. Of course, you see the lights from two headlamps as coming from two different sources because, well, they are two different sources, two different light bulbs. However, what if the car backs away? What if the car is further away? The image of the two headlamps will appear to be smaller. And it will also appear to be closer together as well. What if the car is really far away? The images of the two headlamps might be so close together that it merges into one. Now, imagine that you didn't know that the light was actually coming from two headlamps. By seeing only just one image, you will think that there is only a single light source. Maybe you might think that is a headlamp of a motorcycle, while in fact, that light is actually coming from two headlamps. But your eyes just can't tell them apart. Or in a more physics term, your eyes cannot resolve the image. Hence, the definition of a resolution is it's an ability to distinguish or tell that the light is coming from two separate sources. Now, going back to the quality of the picture. In a high quality image, would usually associated with high resolution, small details can be seen. To achieve this, a camera or any image capturing devices must be able to resolve the image of the 2 points that are quite close together. That's why you see them as different points. However, another camera might not be able to resolve them. So those 2 points will merge into one in the picture, leading to a lower quality. Just like the image that you see here. You see like a small square, right? Everything in that small square are just too close together for the camera to be able to resolve. That's why it's merged into just one big blob. The big question now is how? How does the image of the two sources appear to merge together? And the answer to that is due to something called a single-slit diffraction. Single slit, of course, means only one slit, one gap. In the case of double slit that we have learned before, we cared about the slit separation, the distance between two slits. In the case of a single slit, we care only about a slit width, using a symbol of small b in this case. The diffraction pattern of a single slit will be drawn using the same convention as what we did for double slit. We will draw the intensity function at each point, where the higher the graph is, the brighter the point is. Several questions had asked students to draw this exact pattern before, so you better watch carefully and follow through the steps. First, on the axis, make a mark at the center. Then, make several equal markings on both sides. 3 markings on either side would be good. Some questions might give you the axis with these markings already, but most of the time you need to draw one from scratch. At the center point, mark a dot quite high, indicating a high intensity. That's because the central point is always the bright spot. At all the other markings that you have, they will be dark spots, so 0 intensity. Let's start drawing. Draw from the high intensity at the center to 0 intensity at the first marking. Trying to make the graph looks curvy or sinusoidal, like this. Now, the graph will go up a bit before coming down to zero intensity again at the next marking. If you notice, the peak here is not as high as the one in the center. In fact, when they ask you to draw, you need to draw the intensity of the peaks to drop to roughly a quarter. Repeat the same process for the next one. The peak goes down to another quarter. We can now draw the other side, which is just a reflected image due to the symmetry. So we have seen the intensity function, but how does the diffraction pattern look on screen? The light doesn't just exist only at the peaks, so they do not appear as dots on the screen. To be more precise, the pattern will consist of blobs like these, where the center of the blobs will be the brightest and will get dimmer toward the side. Let me show you the real picture comparing to the intensity function drawn. Hopefully now you understand better of what does the graph mean. Before we talk about the key characteristic of this diffraction pattern, let's name the parts first. The central bright spot is called the central maximum, while the other bright spots are called the subsidiary maxima. By comparing the intensity function with those of the double slit, you should see two different aspects. One, the intensity of the maxima or the bright spots are no longer equally bright. In the case of single slit, the central maximum is the brightest and the subsidiary maxima get dimmer and dimmer by roughly a quarter each time. So you actually don't need to look far from the center before the maxima get too dim to even be seen. 2. The width. In double slit, all the bright spots are equally wide. But in the case of single slit, the central bright spot is double the width of other maxima. So that's the key differences. Once again, question had asked students to describe the pattern of single slit before. Please use the terms correctly. Now let's talk numbers. How wide are those patterns? In the case of double slit, we talk in terms of fringe separation, the distance on the screen from one bright to another bright spot, or from one dark to another dark. However, in this case, we will no longer talk in terms of distance on the screen, but we will talk in terms of angles instead. The key characteristic angle used to describe pattern of a single slit is the angle from the central max to the first minimum. Call it theta. There is an equation to help finding that angle. Theta is lambda over b. This is the only equation involving single slit. So if you see a single slit, please think about this. Once again, the angle theta is the angle from central max to the first min. Angles, not distance. Lambda is of course the wavelength and b is the slit width.